Now in this lecture we discuss the block diagram of feedback amplifier. So this is the block diagram of a feedback network or amplifier. Now here if you see, here we are applying the signal source, here we are applying the signal source. That signal may be current signal or voltage signal, both we can apply here, and here the signal is given to the mixer network, and after that we are giving the signal to the amplifier. Now already what is amplifier, you know that when we are applying signal, Vi signal is applied, then that will be amplified and it is given to the output at the load. Now V0 we are getting. Now what is sampling? In the last lecture I have explained that what is feedback. Feedback is nothing but a part of the output is again fed back at the input is called the feedback. Now here this is the V0 is the output. Now this output is again applied to the feedback network. In this sample here two types of sampling networks are there. One is voltage sampling and another one is a current sampling. If the voltage is, now here you can see voltage and voltage. If we are taking voltage as a sample, then the connection will be, the sampling network will look like this. Here node and one more node. So both we are applying to the feedback network. This is the feedback network. So this is, here it is forming the node. So we can also call it as a node or we can also call it as a voltage sampling. If we are taking voltage as a sample. If we are taking current, then at that time, so this is an amplifier circuit, and from the amplifier current is coming, I0 current is coming to the load. Now from here the same current we have to apply to the feedback network. Now this is the feedback network circuit. So here we are making the connection series. So this is the voltage sample in a shunt or in a node, voltages are same. That's why to take the voltage as sample, we are giving the node connection, here node connection or shunt connection. Now if we wanted to take the current as a sample, then if output is a current we are taking as a sample means what? The same current, output current same we have to apply at the input of the feedback network. Currents are same in series circuit. So here we have given the series connection. So this is also called as the current sampling. This is voltage sampling, this is current sampling. Two types of sampling networks are there, and whatever the sampling signal we required, accordingly we have to make these two connections. Now after that the signal is given to the feedback network. So here beta is a feedback factor and beta is equal to output divided by input. Now for this feedback network, input is V0 and output is Vf. So feedback factor is the beta is equal to output divided by input, that is nothing but a Vf by V0. Now this feedback network is nothing but a combination of RLC values, RLC. Now for example, only if I am using R, a combination of these three also we can take, or any one of the value also we can use. Now if I am taking only resistor, now I can use resistors like this, two resistors I am taking. Now here I am applying the V0, so V0 signal is applied, and by using these two resistors, now I can take, now here it is a Vf value. Now where Vf is equal, nothing but a voltage divider. Now here this current flows the same, so V0 divided by R1 plus R2 into R2. How much we want this Vf value, accordingly we have to choose this resistor value. One of the resistor we have to assume and another resistor value we have to vary. Now if I am taking this R2 as a variable resistor, then how much Vf value is required, accordingly we have to fix this R2 value. So this is about the feedback network. This may be the combination of R, L, C, or all three values or any combination of these values. Now here I have shown only with the R resistor value. So after getting this feedback, feedback signals or sample signal, this we need to apply to at the input. Now input signal is Vs signal and this is feedback signal is Vf signal. If both in the mixer network, we are applying to the mixer network, what mixer network will do? It will mix these two signal and it will give the output value. This mixer output is nothing but an input of the basic amplifier, that is Vi. Now Vi is equal to, here you can see Vs plus or minus Vf. So both signals are added or subtracted. If Vi is equal to Vs plus Vf, then this is the positive feedback. If Vi is equal to Vs minus Vf, then this is called the negative feedback. Whatever the signal we are applying, that is if it is in phase with the input signal, called the positive feedback. If it is out of phase with the input signal, called the negative feedback. Now this is about the block diagram. Now this is nothing but a signal source voltage source or current source. This is the mixer circuit where the signals are subtracted or added. Now this is the amplifier circuit, the gain is A and it will amplify the signal strength. And a sampling network, so these are the two different types of sampling networks are there. Which is signal we are taking, depending upon that we have to make the connection, this connection or this. If voltage, this is a connection, current, this is a connection. And feedback network, now just now I have shown with the two resistors. So this is about the block diagram. Now we will see the Now we will see the principles of feedback network. Now here we will try to derive the expression for the gain with feedback. Now in the last lecture, just now we have discussed as amplifier. Now feedback amplifier consisting of what? Amplifier with the gain A and feedback circuit with the feedback factor B. Now here gain A is equal to, now for this A, this for amplifier gain I am writing, gain A is equal to what? Output divided by input. Now for this amplifier, what is the output? V0 is the output and what is the input? Vi is the input. Now this is a feedback circuit. Just now we have discussed that beta, feedback factor beta is equal to what? Output divided by input. Now for this circuit, what is the output signal? Vf. And what is the input signal? V0. Now here V0 is applied over here. So this is V0. Now after applying the feedback, now this is the with feedback network. This is with feedback network. This is with feedback amplifier, amplifier with feedback. Now for this, if I am taking the gain is AF, AF is nothing but what? Gain with feedback. Now for this amplifier circuit, what is the output signal? V0. So again for the gain with feedback also, what is the formula? Output divided by input. Now for this complete circuit, what is the output signal? V0. And what is the input signal here? Vs. Now Vf is equal to V0 divided by Vs. Now these are the three factors. Now from this we need to derive the AF in terms of the AF is nothing but what? Closed loop gain. So AF is nothing but a closed loop gain. AF is closed loop gain. And A is the gain of basic amplifier. So gain of basic amplifier. And beta is the feedback factor, feedback factor. Now from this we need to derive the AF in terms of AB, gain and feedback factor. Now how to derive that one? Now if it is for negative, now I am taking for the negative feedback. So for negative feedback, if I try to derive the expression for the closed loop gain, then so Vi is equal to, what can we write? Vi is equal to Vs minus Vf by negative feedback. So feedback signal is subtracted from the input signal. Now in this, if we try to substitute those value, now Vi is equal to what can we write? V0 divided by A from the first expression. Now Vs is equal to what can we write? From the last expression, V0 divided by AF. And what can we write? AF is equal to A from the second expression. AF is equal to what can we write? Vf is equal to what can we write? Beta times V0. Now from this we can cancel V0 value. Then we get 1 divided by A is equal to 1 divided by AF minus beta. Now what we want? We want AF. So 1 divided by AF is equal to 1 divided by A plus beta. Now take the LCM. 1 by AF is equal to, if I am taking the LCM, then 1 plus A beta. So now what can we write? AF is equal to 1 divided A divided by 1 plus A beta. Now this is the expression for the with feedback gain expression in terms of gain and feedback factor. Now where A beta is called as loop gain. Loop gain. It is a product of gain into feedback factor. Now this is the expression for the negative feedback. Similarly, we need to calculate the expression for the positive feedback. Now for that, now here for positive feedback means what? Feedback signal is in phase with the input signal. Now here Vi is equal to what? Vs plus Vf. Now again we substitute Vi is equal to what? V0 by A same expression, if we try to calculate, then Vs is equal to V naught by AF plus Vf is equal to beta times V naught. If you try to derive the expression, then you will get AF is equal to A by 1 minus A beta. This is for the positive feedback. In the case of negative feedback, we got 1 plus A beta in the denominator. Now, in the case of positive feedback, we get the 1 minus A beta. AF is equal to A by 1 minus A beta. Now, this is the expression for the positive and negative feedback. Now, effects of feedback on amplifier. What happens if we apply the feedback, then what happens? So, now here the gain is reduced. Now, just now we have derived the negative feedback expression, AF is equal to A by 1 plus A beta. Now, with this what you understood? The gain is reduced. So, but what happens if the gain is reduced means what? Stability is increased, improved the stability. Now, how? If AF is equal to A by 1 plus A beta, then if A beta value is greater than 1, then you can neglect the 1, then you can write it as AF is equal to A by A beta. Then this is nothing but what? 1 by beta. Now, here the gain is depending only on the beta factor. Now, in the feedback network what we have seen, so it is a just a resistive. If I am taking only resistor value, it is a just a resistive. Now, this gain is not depending upon the temperature, transistor parameters or any other parameters, it is not depending. So, we are going to get the more stability, and also noise is reduced. Now, here distortion is reduced. What is distortion? In the last class, in the last session I have explained. So, distortion is going to reduce, noise is also going to reduce, and input output resistance we will derive this in the next class. Now, here bandwidth is going to improve. These are the few effects of the negative feedback. Now, stability of the gain is improved, reduction in the distortion, reduction in the noise, increasing the input impedance, decreasing the output impedance, increasing in the range of uniform application, and increasing bandwidth. So, these two will vary depending upon the type of amplifier. Now, this is given for the voltage amplifier, but in the case of other amplifiers, these two are going to vary. That we will discuss in the next lecture. Thank you.